Hello, welcome to this week 1 TS session on traffic engineering course. So this is an NPTEL course. I'll wait for 5 more minutes since it's 5 minutes to 7, and then I'll get started. I'll wait for few people to join in. Okay, I think we have one person joining in. Yeah. Hi Manjunath. So I'll wait for 5 more minutes to see if more people join in, and then I'll get started with today's session. Okay. Hello everyone. So it's 7 p.m. already. So I'll get started with today's session. So this is the week one TS session in this traffic engineering course. So I think you already had one TS session last Saturday. So I'm another TA of this course. So before getting into the content of this week, I'll introduce myself. I am Rita Bratunath. I am a third year PhD student in civil engineering department in ISC Bangalore. So, my experience with traffic engineering is mainly from my BTech and MTech courses. I don't work right now on traffic engineering, but yeah, it would be a good revision for me as well to be a TA of this course and teaching you the contents of this course. So, now I'll hear from you people. So, there are four people who have joined so far. So, can you just briefly introduce yourself? Like, what are you studying and why do you think traffic engineering course will be helpful to you? So, yeah, we can start with Manjunath. Yeah, okay. Yeah, so what are your plans for future? Like, after MTech, you are looking for a job or you are going for PhD or what? Okay, great. Yeah, so who wants to go next? Maybe Naba Mullika, you can go. Yeah. Uh, or whoever else is available, can you just unmute and introduce yourself? Like, why do you think this course is helpful and what are you doing right now? Yeah, go ahead. Yeah, hi. Yeah, okay, okay. Yeah, okay. Okay, yeah, that's interesting. So, what is your background like? Your studies, I mean, in undergrad or those things. Okay, okay. Oh, great. Mm-hmm. Okay, that's great because I don't come across people like you mostly because it's kind of unconventional, but it's great that you have interest on those fields. Yeah, so yeah, thanks. So yeah, someone else can go ahead and introduce yourself. Okay, yeah, looks like the others don't want to introduce themselves, but yeah, I would like to have this session more interactive if possible. Uh, someone unmuted. All right. Okay, maybe I'll hear from the others as we go along. So let's get started with today's content. So the way of my teaching is generally I like to write on a pad, write on a notepad or tablet as such. But I don't have a tablet with me right now. So what I'll do, I'll probably type it on PowerPoint as we go along. And the main focus of this session is to help you solve the assignment problems that you'll face in week one. And I noticed that the assignment problems are very simple, but anyway, we have to discuss those. Not exactly the problems that are given in the assignment, but similar type of problems I'll be discussing and maybe asking you to give answers as we go along. So I'll create some questions from the lecture slides, and maybe we'll discuss those topics and as the session progresses. So I'll share my screen and get started. Okay, so I think it's coming up. Okay, can someone confirm if it's visible? Okay, great. So as I have already introduced myself, so let's talk about the topics that have been covered in week one. So first, it's traffic engineering objectives. So this has been discussed. Then the thing that is mainly discussed was mobility and accessibility, and I think the very first question of the assignment is related to this. And then you have traffic engineering elements. Next you have components of traffic stream. Then within that you have four types of components. So let's discuss these topics briefly one by one, and then we'll take some questions and examples, and we'll answer those. So can anyone tell me what is the objective of traffic engineering? I think this has been discussed in the class and it's very simple, I think. And I'll write it down here. Okay. 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 Yeah, all these points are useful as you have mentioned, but yeah, objectives are, there are primary objectives and there are secondary objectives as well. As you have mentioned, safety is the primary objective, and I think you will get one question related to this as well in one of the true false. Then there are other objectives as you have mentioned already. So these are speed, which is related to mobility that you have talked about. Then I think you have talked about convenience. Yeah, that's one of the point that definitely comes. Then the others are comfort, economy, and I think environmental friendly, environmental compatibility, that's already mentioned. So yeah, and this too that you have mentioned here. And I think I have missed one. Oh, I think that's all. Yeah. So this is very simple. Then the next terms that we came across is mobility and accessibility. So there is some difference. Okay, let me check. Someone joined. Yeah, so can anyone tell me what's the difference between mobility and accessibility? Maybe the definitions or difference, whatever you call it. Yeah, correct. So this is related to proximity of land or ease of like accessing some modes of travel and so on. And mobility is something which is related to, say, uh, the throughput or the speed that you can mention. So depending on this, so the formal thing is relative ease of movement, and this is for accessibility. Yeah, gain entry to a desired destination on proximity of land, those kind of things. So that's perfectly fine. So now let's answer one question, because the first one, it's very much related to this. So let's talk about mobility and accessibility a bit more. So these are there are different. So can what is the relation between mobility and accessibility? So options. So what could be what what would be the answer to this if I ask you this question right now? Or if I frame it correctly, mobility function and accessibility function. Okay, so let me define it in a simpler way. So suppose accessibility, suppose you want to go from your, say, home to a marketplace. Now, the roads that are accessible to you, it's just if you go out of your house, the road that we call it as a local street. So that's easy to access to you. So you can go to that street directly out of your house. So that means that local street is more accessible to you. But suppose you want to do a long distance trip and you need to go to an expressway, and from there you have to go through a car and so on. That expressway is not very much close to your whole house. So in that case, what happens is that expressway is having less accessibility to you. On the other hand, suppose mobility, if you take mobility, through the local street, there could be, say, auto rickshaws going, cycles, and other modes of travel, different modes of travel that are happening. And the relative ease with which you move, suppose you think of it as speed, that is slow as such. So probably you are walking through your locality and then availing some auto rickshaws and so on. But if you look at, if you have reached the expressway and you are taking a car and so on, then in general, if there is no traffic congestion, you can move very fast through that expressway. So that means it's easy to move through that expressway. So that means it's more giving you more mobility compared to a local street. So that's the difference. Accessibility is kind of like a door-to-door access that you can think of. Mobility is very much related to speed. That's the way. So uh, mobility of an aeroplane would be highest in that regard, but for having to avail an airplane, you have to go to the airport, and it's not like you step out of your house and you reach an airport. So that's not easily accessible to you. So these are the subtle differences that are there in this. So now if I tell you, suppose now hopefully it's somewhat clear to you. Now the mobility function and accessibility function, I think if you remember in the lectures, there was a graph that was shown in that lecture. And suppose I give you an example of aeroplane. So it has a high accessibility or low accessibility in that case. Suppose I give you, correct. So that's low accessibility. Whether it is having high mobility or low mobility. Yeah, correct. Now suppose I tell you, let's take another example. let's car, is it having higher accessibility than aeroplane or not? Okay. Now if I ask you whether it is having higher mobility than airplane, yeah, correct. Similarly, now let's talk about bus. Is it easily accessible than car, or it's less accessible? Yeah, that's correct. So if you have a car in your house, then that's fine, right? It's easily accessible to you. But if you're not having, so then car is not easily accessible to you. Bus is easily accessible to you in that case. But I think here what I've been shown here is that bus is less accessible than car, assuming that you have a car, or you can easily get an Ola and Uber because it's a door-to-door connection. You can call an Ola and Uber to your like close to your house, in front of your house. But in order to avail a bus, you cannot just directly step out of your house and get a bus. So you have to go to the nearby bus stop. So in that regard, it is less accessible than car. Now, in terms of mobility, whether it is less mobile or like high mobile than car, I think this one is simple, right? It's having less mobility than car because you can travel faster in a car, and bus will wait for passengers, and those kind of delays will always be there. So yeah, I think this difference should be clear now. So these are related to the travel modes you can think of, and then there is another kind of classification that is related to the streets you can think of. So let's can you tell, someone can tell me type of urban roads? Yeah, yeah, arterial roads. It has two uh, like divisions, major and minor, or I think sub arterial is also fine. Next, correct, yeah, collector streets, and here also you can have major and minor, and finally the local streets. Okay, I think someone joined. Yeah, so now if we look at this classification is done in such a way, so there is an ordering of uh, accessibility and mobility here. So can someone tell me what would be the ordering of accessibility for all this? Yeah, correct. So it should be in this order. Right? And what about the mobility order? Yeah, correct. So in a way, they are kind of inversely proportional. The function, it's kind of a decreasing function that you can think of. Okay, so that answers our question. And also, if you go back to this assignment one's first problem, I think from here you can now easily answer what would be the correct options from here. So there can be multiple correct answers as well. So you have to be careful in choosing that. Okay, so I think next is basically some of the definitions. So we'll get into this and talk about the next portion. So let me open another slide. Okay, so let's see what are the next topics that were covered in the class. Okay, so let's now talk about traffic engineering elements. Okay, so can someone tell me what are the traffic engineer elements are? It's very basic, like okay, I think sorry, I couldn't hear you. Okay, so that's somewhat different. That is like components of traffic stream. This is something different. It's kind of related to the measures that you do: speed, travel time, delay. Yeah, yeah, those things, correct. So it's related to that. So it's speed, travel time. Yeah, I don't know, like this classification could be done in a different way. I don't know why it is called as elements as such, but yeah, traffic volume. Then I think you have demand. I think there is one question related to demand as well in one of the assignment problems. Then accidents, delay, and I think it is talked about in the class that why all this analysis are required: accident studies and this delay measures and traffic volume calculation, speed, travel time. And these things will be discussed in detail in the next few lectures. So it's not like we'll be going into the details of it right now, but I think these terms are kind of defined in the slides itself, and I don't think there are a lot of questions asked from this right now. But in I think in your assignment 0, there were a few problems related to this. One is, I think, related to this jam densities and so on. Then I think another was yeah. Does anyone have a question? You can unmute and ask. So yeah, this thing will be talking about again in later classes, because it's not covered as such in week 1, but later it will be covered. So the other things that are talked about are performance evaluations, where these things are mainly this level of service. Then there is something called, I think, next facility design. It's not kind of required right now. Okay, so let's talk about facility design a bit. So I think in the class it has been discussed that it could be some structural design that you have to make, and traffic engineers are not concerned with that, and that is true. So by facility designing of for traffic engineers, it is mainly functional and geometric design of highways. And other traffic facilities. Now, if someone asks you whether it is related to the structural design, that's not true. And let me check if there is something related to this. Okay. Okay, it's not there in this assignment, but I think it was there somewhere in previous assignment, or it's in one of the options probably. Okay, so these things are fine. I think it's not that difficult to understand. Traffic control operations. Yeah, let's talk about traffic systems management next. So what do you mean by traffic systems management? If I ask someone, can anyone tell me? Okay, okay, let's write down your point. To make traffic as uninterrupted as possible. Okay, that's true, but how do we do it? Uh, it's like technology is one thing. Sorry, can you repeat? Okay, great. Yeah. And operation of. Okay, okay. Operations, for example, say carpooling. Okay, so now let me ask you one question. Suppose I want to start an electric bus fleet in a city. So, as a traffic system engineer, what are the things that I should manage if I want to start electric vehicle fleet? Ele- Yeah, electric bus fleet, suppose. Yeah. Okay. Okay. That's a good point. Hmm. Okay. Okay. Great. Next. Yeah. Okay. Anything else? Okay. Okay. So let me now ask. Demand is something that might change over time. That's fine. Now, suppose you have the charging facilities already decided and they are already placed in the network, and you have also have some sort of a schedule that how long will this buses run and so on. Now, on a day-to-day basis, what are the managerial decisions or as an operational decisions that you think that you might have to take in order to run this system smoothly? Yeah, yeah. Mm-hmm. Okay, okay. Mm-hmm. Okay, yeah, great. So yeah, I think mostly you have covered most of the things. One thing that was probably missing was charging schedules of buses that you also have to need to manage, because it's not like I'll decide this bus will run for 50 kilometers only. It might happen that it will run out of charge, but you have to charge those buses in between during the day, and it will again do some other trips as well. So that's one of the important points to keep in mind. And for this, yeah, the technique that we use, it's kind of this optimization that you can think of. And yeah, optimization is part of, say, this system capacity management as well. And then probably a public transport system that you are opening, there also optimization is helpful. And in addition to this traffic systems, this one that we talked about, this example, the other examples could be this automated toll collection. I think this was mentioned in the lecture slides as well. Then in vehicle GPS, and with that you can actually track a lot of things. Maybe you want to collect a lot of data from Ola and Uber. I know they don't make this public and so on, but GPS can help you in deciding where the demands are and what the system requires in the future to enhance it more and so on. So yeah, these are some of the examples of this traffic systems management. And here I think something is carpooling. Yeah, already that is mentioned. Pricing strategies, that's another important point. So maybe you can think of not only in case of, say, tolls, or maybe if you think of this carpooling, Ola and Uber, these things, what should be the optimal price that you should set for people like want to move from point A to point B, those kind of things. And this is important again to, say, manage demand, to reduce traffic jams and so on. Okay, so then there is something which is ITS, Intelligent Transport Systems, and that have been, I think this is all part of ITS that we have discussed already. Okay, so I think that's all we can discuss on this traffic systems management, which is relevant for now. Let's move on to this component of traffic streams, and then we'll address some of the assignment problems that we might get related to this. So I think somebody answered this questions already. So there are 4 components. So can anyone tell me? Okay. Okay. Yeah, that's correct. And now control devices have some more classifications. Can you remember those? Okay. Yeah, traffic signs, those things. Yeah. Then I think del yeah, signals. Yeah, I think there are 4, right? I think, yeah, there were 4 that have been discussed in the class. Correct. And now let me ask you, which are the controllable part of this and which are the uncontrollable part of this? Okay. Okay. So if I ask you why, can you explain? Yeah. Yeah, correct. And roadways, why is it controllable? Yeah, and this one, as the name suggests, it should be controllable, right? Yeah. So these are the controllable and uncontrollable factors, and then there is something I think discussed was environment. So here I think this weather, then local enforcement policies and so on, density of development, all these factors will probably have an influence on how the traffic stream uh, works or reacts. So I think after that it was mainly a discussion on all these components in detail. So let's first see what are the relevant uh, assignment problems that we might get here. So let me open the assignment. Okay, assignment one. Okay, so let's solve one of the questions. So it is relevant to, say I write it as now. You have, say, two columns and four rows. Sorry, five. Here it's a column A. So it's a matching kind of a problem. Here I have written traffic characteristics, then control devices. Next is transportation systems management. Just now we talked about these things briefly. And performance evaluation. Okay, in column B, let me write operating characteristics of facilities. Then you have optimizing system capacity and operations. You have controllable component of traffic stream, and finally you have measuring and quantifying several aspects of traffic. Now you would get such simple problems here. So let me mark it as 1, as 2, 3. Okay, so what would be the answer to this? I think it's very simple because it's just okay. Okay, so let's write it. So you're saying 1 is 4, 2 is okay, and yeah, okay, let me check if it's correct or not. Traffic characteristics, okay, measuring and quantifying several aspects of traffic, control devices, controllable component of traffic stream, transportation systems management, optimizing system capacity and operations, performance evaluation, operating characteristics of facilities. So can anyone tell me if it's correct or not? Yeah, that's fine, right? And these two are very much simple, 2 and 3. Maybe it's somewhat confusing with performance evaluation, and here also it's talking about some measurement and quantification, but actually it's related to this one, and this is related to traffic characteristics. uh, yeah, I think that's correct. Yeah, this is correct, although this has characteristics words in it, but there is some difference in these two things. Okay, so that's, I think, one of the questions related to this. um, Next, let's talk about some parts we haven't discussed yet. It's the okay, someone joined, I guess. Okay, so I think we didn't discuss about some of the basic definitions. So let's talk about that because there is one question related to this. Okay, some basic definitions, like in few words, maybe you can explain. So this one is environment, then economy, then you have convenience and safety, and these are also the objectives that we have talked about. So what do you mean by safety? uh, so this is the primary objective, right? So we have already discussed this here. This is okay. Next is convenience. So what is convenience? What do you mean by this? Sorry, I couldn't hear. Yeah, yeah. Easy way of making trips. What do you mean by economy? It's very simple, right? Yeah, correct. And this we already talked about, right? Uh, so maybe you can think. Um, Sorry. Okay. Yeah, that could be one of the objectives for environmental friendly travel, but that's not always possible though. Yeah, that's true. Yeah. Okay. So sorry, your voice got cut. Can you repeat what you said at the end? Okay, yeah. So it, yeah, go ahead. Yeah. Yeah, correct. So it's not like it's yeah. So here I think the focus is only on road user point of view. So it's suppose you want to travel say 2 kilometers, you wouldn't want to be paying say 100 rupees for that. Maybe it's there are some cheaper alternatives where you can take 20 rupees auto rickshaws and so on. But economy, in a broader sense, you can think of it as if you are a planner, traffic engineer, planner, or a system planner, whatever you think of, then obviously you have to design your system in such a way that whatever you invest, you should get returns from it, like over a period of time. So yeah, it works kind of both ways, but here the emphasis is on road users. Yeah. So yeah, I think it's assignment problems are that simple. So that's why it's yeah. I think for a I think 5 minute assignment that you can solve in 5 minutes, for which I think 2 hours have been allocated in this session. But anyway, we'll discuss all these things. Okay, so I think yeah, this has been covered already. Okay, so in this context, let's talk about some true false statements because this will appear in the assignments. So first I can write, so this is related to economy. So economy of a nation depends on efficient movement of goods. Is it true or false? Yeah, so here economy is from another perspective, right? So here there is another example of it. Next, I think let's talk about uh, yeah, minimizing the impact of transportation systems on the environment is not the objective of traffic engineering. Do you guys think this is true? Yeah, these questions even you can answer from your like basic sense as well, so that's fine. Yeah, and I think let's talk about something that is relevant. Okay, some more let's solve some more of this. Okay, so can someone define what is level of services? So you know, right? There are like 6 level of service by which you can classify. Yeah, yeah. So it's uh, generally quality and performance of a facility. By facility here, I mean like the infrastructure, road infrastructure you can think of. So yeah, that's kind of simple. So this is, let's look at now true false problems. Uh, do you think this is true? Yeah, yeah. This should be false, right? Because intelligent transport system generally doesn't kind of encourage this curb management, one-way traffic systems, these things. It's very much different. ITS involves some technologies and so on. So yeah, it's not related to that. And yeah, this question is actually was very confusing, but the correct answer here would be false. Okay, I think there is another which says whether lighting are a part of traffic engineering components. Yeah, we have talked about traffic engineering components. Here, do you think these kind of play a role? Yeah, that's true because it's part of the environment. Okay, so yeah, these are some basic steps, and this one, so curb management and one-way traffic. So these actually come under traffic operations, not kind of ITS. Okay, so let's see if there is something. Okay, let's move on to another topic and then we'll answer the rest of the problems. So let me go back and see what have been discussed in the class. Okay, so let's start with this traffic components and characteristics. So let's talk about road users first. And once we come across road users, the first important thing that have been discussed is visual acuity. So what do you mean by visual acuity? Can anyone tell me? Sorry, I think it's spelling. Yeah. Okay. Mm-hmm. Yeah, correct. Yeah, yeah. So ability to see small, like stationary details. Yeah. Okay. So now let me ask you, what do you mean by 6 by 6 vision? Can anyone formally define it? But what are the significance of this number 6? It should appear somewhere in the definition, right? Okay. 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 But where does 6 come? Okay. Yeah. So ability, say, to recognize an object from a distance of 6 meter. Now let me ask you, what do you mean by 6 by 9 vision? What would be the answer to this? Yeah, can anyone tell me the answer? Okay, so here you can think of it as a proportion. So 6 by 6 is kind of a normal. 6 by 9, when it is written like this, you can think of you are having kind of a 6/9 of vision of a normal person. So that means a normal person might see an object from a distance of 9 meter, but you are only able to see that object from a distance of 6 meters. So you have to move closer to have like perceive or see that object. So that's the difference. So here the definition is relative to a normal person. So suppose, so normal person can see the object or can recognize, I can write, from a distance of 9 meter, whereas the person in concern recognizes the same object from a distance of 6 meter. So is that clear? No, no, it's not like that. Normal person, so suppose an object is 9 meter away from you, you are seeing that object, but the other person cannot see that object from 9 meters. The person has to move closer to that object, like he or she has to reduce the distance by 3 meters, then only or she can recognize that object, right? So it's like they're not having a normal vision. uh, by moving closer to the object, then only they are recognizing the object. So that's the difference. Yeah. Here you can also define it in term relatively to a normal person. So a normal person recognizes that object from a 6 meter distance, and the same object you are also recognizing from a 6 meter distance. So it's like you can think of it as a proportion. So you 6 by 6 is 1, right? So you are having a vision of 1, say. Here it's 6 by 9 vision means, if you think of it as a proportion, it's 2/3, like 66% of a vision of a normal person. You can think of it in this way, though it's not a formal way of defining it. But yeah, the formal definition is this one in terms of these distances. Okay, so I think you will find probably one question related to this. Yeah, so it will probably ask you whether he or she has a better vision. 6 by 9 person is having a better vision than 6 by 6 person or not. The answer is obviously no. Now let me ask you, uh, is there something called 9 by 6 vision? Is that possible? Now if I just flip it, is that possible? Okay. Yeah, it's like it might be, I'm not sure, because the one that we term as normal is one who is having a recognition of that object from a distance of 6 meter. But if someone is having more ability, that, so I don't know. So it's even I don't have the answer, so it's better not to go here. But anyway, it's in terms of, you can think of it as a proportion kind of a definition, where the first number should be less than or equal to the last one here. So let's erase this one. Anyway, so that's fine. Visual acuity, I think we have already discussed. Next, let's see what was there in the material. Yeah, field of vision, it's something that have been discussed. And here I think there were few classifications of vision. So can anyone tell me what are the three classifications that have been discussed? Yeah, yeah, yeah. I think these definitions were discussed in the class in detail, so I'm not going into it. And also how these are kind of related to where you need to place those traffic control devices and so on. Those are directly related. So yeah, peripheral vision examples and everything I think was discussed clearly. Then yeah, there was some talk on visual deficits and so on. That's fine. Yeah. Next, I think this perception reaction process. So let's quickly. So this is called PF theory. So what are this abbreviation stands for? So this is perception. This is intellection. This is emotion. This is volition. This I and E, this portions are involved related to the brain, and the other it's kind of stimulus and the response. So yeah, these things I think you know from your BTech level as well. Very basic steps. And yeah, the reaction times and those things, recommended values and everything, that was I think presented in one of the tables. So that's perfectly fine. I don't think there's anything more to discuss. Then there were some physiological, psychological, physical factors that might affect travels and so on. Yeah, and then there were some talks about pedestrian. So this pedestrian crossing signals and everything. So let's see if there is something that's relevant. Okay, so let me ask this. So it's a pedestrian walking speed, and I mentioned that 20th percentile of walking speed. So what do you mean by this? So does it mean that the pedestrians that are walking with says the speed, which we might call it as v, it is like 20% of the people are having more speed than that, or 20% of the people having less speed than that? Okay, uh, let's think, was it discussed in the class? Just check. Okay, so what I'm asking is that, so what would be the correct one? Yeah, I think this is not relevant for now, but this will be related in the later lectures. But I'm not sure whether this question was asked in the assignment or not. But anyway, since I think it's not relevant and you don't seem to remember, so actually, yeah, this is like 20% of the pedestrians walk slower than the speed. So yeah, it was just in the context of road users, and it will come up again later. Yeah, yeah, go ahead. Yeah, suppose this is v kilometers per hour, some value, uh, and this speed is this v, right? Yeah. So suppose I tell you that the 20th percentile of walking speed of pedestrians is say 5 kilometers per hour. Then that means 20% pedestrians walk slower than 5 kilometers per hour. 80% walks faster than this. So it is kind of relevant in design aspects and so on. But yeah, not relevant, right? Okay, so let's, I think, get into something else. Maybe the other components. Next is vehicles. I think that have been discussed in detail, and there is not as such to discuss. It's like more informative stuffs and so on. Weight, dimensions, braking, accelerations, those things. Then there were some mentions of IRC code where this classifications of roadways have been given, so that you already know. So let's briefly maybe talk about this. So classification of urban roads that we have already discussed today. That is, I think, from IRC 69 you can get. I don't remember the latest version, so you have to check which year that comes up. Then there is classification of rural roads that we haven't discussed today. So can anyone remind me what are these? I think these are national highways, state highways, major district roads, then village roads, and this is from IRC 73 if I'm not wrong. Yeah, correct. So these are described. Then there is traffic control devices. Road delineators are kind of to guide the traffic where there are bends and so on. In night times those are useful, so we won't be discussing that in detail. Let's get into the traffic control devices. So, and with that, maybe I'll stop the discussion on this and go on to the assignment problems solving. So one, this is road markings. The critical thing here that you might have to remember is this is relevant to this IRC 35 code. And the other stuffs are this color, this one, So it's white versus yellow. Then there is blue and green markers as well. So can anyone tell me what are these used for in road markings? White, blue, green, yellow, these things. Okay, 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 okay. Mm-hmm. Oh, those are the boards and all you're talking about. It's something different. This is road markings. These are markings on the road. It's not the boards. Okay, okay. Yeah, correct. Green is, I think, related to cyclists. Yeah. Yeah. Okay, blue is, yeah, correct. And white, it's in general you have seen a lot of white markings on the road, right? Zebra crossings and those things. And anyway, these are for good visibilities and so on. White markers on black roads or grayish roads. Then I think there is other markers, red markers. Yeah. Okay. Then what is mostly these are informative, the things that are discussed. Next is, I think, traffic. Yeah, examples. Give way sign, I think. Can anyone tell me how does it look? Yeah, correct. It's not, yeah. Okay, yeah, right. You seem to remember well. Yeah, correct. And yeah, I think these were discussed. Next was traffic signs. So these are kind of memory based, I felt. It's not like you have to understand a lot of things. So there are three types of traffic signs that have been discussed: regulatory, warning, informatory. And this is, I think, comes from IRC 67. So regulatory signs are kind of uh, they're round in nature. Those things are there. Stop signs, which is octagonal, or yeah. So circular or octagonal in shape. Then this is kind of related to traffic laws, regulations, and prohibitions. Yeah, I think then it was discussed. Different signs were discussed. I think some one-way signs, horn prohibited, cycle prohibited, no parking, speed limits, width, height, this length limit. So it's fine. I think it's informatory in nature. Then warning signs. So what's the shape of this? Yeah, correct. And here it's like, you can think of men at work, those things. Intersection is there, crossroads, school ahead, hairpin, those right hand curve or left hand curves, and those things. Then there are informatory signs. The one I think someone said about this boards and so on in green. So those are informatory signs, like which direction to go for, whether Delhi is like straight or left on the right side, those kind of informations. So it's to like guide the users along their routes. Green background, rectangular image. Yeah, so some basic things I think. Then I think we can talk about signals. So you know that red, amber or yellow. Okay. So discussed. Okay. So now trying to find something. Okay, was it discussed in the class? Just okay. Probably it was there in the assignment. Yeah, it was related to say uh, color blindness. So what what pigment is added to green lights to overcome the difficulty of colorblind drivers. Yeah, I think was this discussed in the class? I'm not sure. Probably. Okay, so for green it is blue. That's correct. And what about, yeah, yeah. So let's, I think, actually yellow is added to red light, right? So if I So here the answer would be yellow, right? Okay, I think, yeah, let's move on to the next part. So I think I mostly covered the content that have been there in the course material. Now let's get into some of the specific problems. I think we have seen one or two, but let's complete this. Okay. So now the mobility and accessibility we have talked about. Okay, this is, okay. Let's this is called some providing safety and efficiency is a complex job in multimodal system. That's true, right? It's a complex job, so it's, I don't think I need to explain it more. Then think, yeah, let's talk about this one. Facility design of transportation facilities refers to the structural design of the facilities. Is it true or false? Yeah, and there was another point, I think something related to functional. I had written it here. Facilities, okay. Is it? Okay, let me check quickly. Oh, it's a functional and geometric design of highways and other facilities. Yeah, so this will be false. And then I think this, this is also discussed. Okay. Okay, what would be the answer to this? Yeah, and the correct one? Okay, yeah, that's true. Okay, so let's see. Okay, what would be the answer to this? Okay, so is it true? What about others? What do you think? Okay, is it informatory or regulatory or any other wording? What? Which one? Is it? Okay. Okay, so you are saying it's false, right? Correct. Hmm. Hmm. Okay. Okay, so let's say this is false. Now let me write this. Yeah, it's false. That's correct. What would be the answer? Uh, Let me check. Think it was there in the class. Quickly I'll tell. Okay, so informatory road signs are not kind of related to like the immediate danger that might happen. Those things. It's not like just providing the information to the road user. Informatory signs are kind of related to like the directions, like which city in which direction, or if there is a hospital ahead, or like some public telephone, restaurants, those things. Those fall under the category of like informatory signs, what I understand. Maybe some parking spaces and those things. In terms of regulatory sign, let me check. Those no parking, those things are there. Something which is prohibited, that's true. Stop, give way sign. Speed limit, that falls under regulatory ones. And when there is you're approaching an intersection, it's kind of, I think, related to this probably right or left hand curve or right left hairpin bend. Those things I think are more related to this approaches at intersections. So I think it should be warning sign. This answer should be true. This one should be false. Yeah. Okay, so we have still half an hour, and let's see if we can solve some more problems. Okay, so continuous road markings are provided in case of no overtaking situation. Yeah, this is true. Yeah, correct. It's true. Okay, this is fine. Let's solve another. Is it true or false? Yeah, correct. Yeah, go ahead. Hmm. Yes, correct. Correct. Yeah, that's okay. Next, say reaction time of what would be the answer to this? Yeah, yeah, it's very simple, I think, and yeah, any answers to this? Yeah, I think it was discussed at the very beginning. One thing influences the other, so it's kind of a cyclic in nature, so this should be false. Okay, so I think this discussion is fine for the assignment. So since I have some time, maybe I'll just create some more questions and we can answer. Okay, let me see which are the things that are relevant. Okay, let's okay. Is it true or false? Yeah. Okay, I'm writing this down. You can answer it. Okay, let's now take a simple problem. I think it was their assignment. Yeah. Okay, so let's take this, the average spacing between the vehicles is found to be 8 meters under the jam condition. Estimate the jam density vehicle per kilometer. Okay, so how would you approach this problem? What would be the answer to this? Okay, so 0.125. So it's, you are saying 1 by 8. Okay, but is it vehicle per kilometer? So this is vehicle per meter, right? Because this is 8 meters. Yeah, correct. So it's 1000 by 8. So this will be vehicles per kilometer. So that will be, I think, 62.5, is it? No, 125, sorry. Okay, this is simple. I think this was there in one of the uh, assignment 0 questions probably. Then I think there is something relevant. Okay, space means speed and time means speed. These things will come up later, I think, anyway. But yeah, I think we can discuss them later when it comes up in the course. Let me see if there is anything else to be discussed. Okay, I think I've covered a lot of things already from this assignment. Okay, so let's see. Let's move on to another. Okay. what would be the answers to this? Okay. Yeah. Yeah, what would be the answer? Yeah. And this one? Yeah, correct. Okay, this is easy. Okay, let's take one more kind of a problem. Okay, so how would you solve this problem? Although it's maybe will be coming up in the later lectures, but I think it was there in week 0 assignment. Okay, it's similar to before. It's 1 by 3, that's vehicle per second. Now for vehicles per hour, what you have to do, you have to multiply it by 3600, and that gives you the answer. Yeah, these things will come up again later as well. Okay, so let me check. Okay, I think I've covered most things. So do you guys have any questions? Otherwise, I'll probably stop the session at 8:50 or so. Yeah. That I'm not sure of, because these NPTEL lectures are kind of structured in such a way that the videos are already made, uh, the lectures that have been posted in every week. So even I have not seen the upcoming lectures and so on. There may be or maybe not. In terms of TA sessions, also, like, I cannot ask any guest lecturer as such, or guest expert to come and give a talk, because it's purely up to me to deliver and mainly to focus on solve assignments. So I'm not sure if you'll get a first-hand access to a traffic engineer as such, but I think there will be one or two, maybe two sessions with the faculty itself, live sessions. There, I think you can ask him whether it will be possible to arrange for such sessions, or even he might say something during those live sessions. And yeah, that's all that I know right now. Uh, And maybe if you have any doubts or suggestions or anything, you can always post it on the discussion forum uh, in this course. So there, I think the other like faculties or the TAs, the main TAs of the course, the ones who will check the assignments, they'll probably notice those messages, and then probably they will reply to those. Yeah. Okay. Anything else from anyone? Yeah. Thanks. Yeah. See you next week then. Yeah. 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 You too. Yeah. Yeah. Thanks. Yeah. Thanks.